Good afternoon, my name is Eugene Bryce from Bryce Energy Services, and I'd like to quickly show you our new electric charger calculator. So go to Bryce Energy Services, so bryceenergyservices.com, and you'll come to our homepage. Now, before I go into the electric charger calculator, feel free to have a good browse around our website for the services we offer, our partner services, but also in particular other YouTube videos that are available on a number of energy and carbon topics that may be useful to you. So back up to the top of the page, and for the next month or so I'll keep the calculator button highlighted red. We also have a carbon footprint calculator, so feel free to use that after. Electric charger calculator, so dive straight in. So the idea here is if your business is considering an electric charger or a number of electric chargers, what impact will it have on your business in terms of your electricity use, your carbon footprint, and also if you decide to commercialize your array of electric chargers and charge people money for the kilowatts and parking space. So I'll fly down through. Each area has notes that you're welcome to read. So how many are we installing? I'll say we're installing 4 chargers at 22 kilowatts each. So that estimates the hardware at £22,000. If I selected 7 kilowatts, 4 of them is estimated at £7,000. Now, those costs would exclude any upgrade works to your electrical network within your premises, and also any upgrades to the DNO network. So if I select my 22 kilowatts, I've estimated £22,000 because of £250 per kilowatt is the simple equation. I've added an extra £10,000 to allow for DNO and other electrical upgrades to bring my total charge, or total costs I should say, to £32,000. Existing electricity supply, so let's say ours is 250. Your electricity capacity in kVA, so this is how much power you can draw from the network at any one time, and you'll find this on your energy bill, and I'll just say 100. Your electricity day rate, so again from your electricity bill, I've said 19 pence and 11 pence. Time of day utilization. So this is where it gets a judgment call in terms of how often and how frequently will your electric chargers be used. As it's a chicken and egg situation, when you get chargers, you'll find more electric cars are using them. So initially I've set my weekday daytime use, and when I say daytime, between 6 a.m. and midnight, because it's daytime electricity rate use. So 50% is high, so effectively that's would be equivalent to full-time working hours. Nighttime use, I'll set it a little less, so this would be somebody charging their car overnight. Weekend daytime use, again, I'll set it to 20%. Perhaps you have staff in over the weekend who may charge their car. Actually, that's probably a bit high. I'll just drop it to 10%. And excuse me, that was weekday, wrong one. I'll drop that to 10%. Nighttime use for daytime at the weekend, and then weekend nighttime use we'll just set to 0 because we won't have staff working weekends, nights in our example. That gives us totals then of total charging hours, total charging kilowatts, total charging cost £45,000, which is a lot of money obviously. Total hardware cost £32,000. So straight away you can see that the use of electric chargers relative to the hardware cost, the energy is basically, the cost is the actual charging. Current supply capacity, or I should really call that present supply capacity, 100 kVA. With the chargers we have selected, we need an additional 105 kVA to bring the new required capacity to 205, which is a significant step change in the existing supply capacity. And that will be the biggest problem most businesses face. The question of how do we get the required electricity capacity to charge the electric cars in our maximum kVA to chargers. Now, this is a little function that sets down the kV on the chargers. Now let me set this back up to 22. So we can see here that we're doubling our kVA. So this basically limits by percentage from, let's say, a 22 kilowatt to an 18 kilowatt to a 15 kilowatt to a 10 kilowatt charger. Next. So selling price, if you want to commercialize the chargers, then you can charge by hour, pounds per hour, or per kilowatt. So we're defaulted 45 pence per kilowatt selling at daytime and 35 pence per kilowatt selling at nighttime. And working the figures through, and I'll leave it to read. So these are the selling per time band. That leads us to, with a selling of £4.50, we actually don't get a payback on our hours only. If we look at our kilowatts only, because our kilowatt rate is so much higher, we get a payback on our £32,000 investment in half a year, which is quite good if you get the assumed utilization. If we use both time and electricity, we improve our payback from half a year to 0.4 of a year. Finally, we have greenhouse gas emissions, scope 2 and scope 3 from electricity, and this gives us the figures based on 2021 greenhouse gas conversion protocols, and the new total scope 2 and scope 3 to 115 tons of carbon dioxide. So that's a brief run through the calculator. If you would like a copy, simply enter your email, click you're happy, and submit. So once you submit, you're taken to our actions from electric charge calculator page. You'll see a short summary of the numbers that you have entered. So this is the email that you will get from the electric vehicle charging calculator, and basically a summary of the results from the calculator, the parameters you entered, the payback periods for the different options based on these rates, and a summary of the greenhouse gas emissions. So the changes based on your electricity bill to the government reporting factors. And then below, just a full list of all the data entered, that including that summarized above. So please get using our electric charging calculator, and please feel free to comment and let me know your feelings about it. Thank you very much.